Okay, this is Jacob's Algebra, Chapter 8, Lesson 4. So the new rules that are covered in Chapter 8, Lesson 4 are that any number to the 0th power is going to equal 1. The exception to this is that x cannot be 0. 0 to the 0th power is undefined. Then there's x to the negative a is equal to 1 over x to the a. And again, this is as long as x does not equal 0, because if x equals 0, then we're going to be dividing by 0, and that's undefined. So for both of these, x cannot equal 0. And then we have, if a and b are integers, then x to the a times x to the b is equal to x to the a plus b. We already had this rule, but we're clarifying that this rule also applies when a or b are negative. And again, if a and b are integers and x does not equal 0, then x to the a over x to the b is equal to x to the a minus b. That's a minus there. And then, of course, again, if a and b are integers, then x to the a power raised to the b power is equal to x to the ab. So that's a times b. So these three down here are old rules that we got in lessons 2 and 3. And then up here at the top are our new rules. They're the special cases when you raise something to the 0th power or when you raise something to a negative power. So basically, when you raise something to a negative power, you flip it over into a fraction. So x to the negative 2 is 1 over x squared. 1 over x to the negative 2 is just x squared. We flipped it over. It was on the bottom of a fraction. Now it's on the top. Okay, so now we will start some examples. So we're going to look at number 4, which says write each of the following numbers without using any exponents. So 4a is 1 to the 10th. Well, you think about that. 1 to any power is going to be just 1. So that's the answer. B, 10 to the first power. Well, it's to the first power, so it's just 10. For C, 0 to the 7th power. Well, 0 to any power is going to be 0 because no matter how many times you multiply 0 by itself, it's still 0. Okay, D, 7 to the 0th power. Okay, that's our special rule for the 0th power. Any number to the 0th power is just 1. Okay, and then E, we have negative 1 in parentheses to the 6th power. Okay, this is where you have to be careful. If you raise a negative number to an odd power, you are going to have a negative answer. A negative number to an even power is going to give you a positive answer. Negative 1 to the 6th is positive 1. Now, that is only if the negative is inside of the parentheses so that our exponent applies to it. Okay, we're going to skip down to part G. We have negative 2 to the 5th power. Okay, this is to the 5th power. That's an odd power, so our negative stays. And then we need to get 2 to the 5th power, so we just count by 2's. 2, 4, 8, 16, 32. So it is negative 32. Okay, we're going to do part H. We have 5 to the negative 2. That means it's going to be 1 over 5 squared, because this negative means we flip this from the top of a fraction to the bottom, and 1 over 5 squared is 1 over 25. We're going to skip down to part K. Part K is negative 4 to the 3rd power. Again, this is a negative number that's being raised to an odd power, so we're going to have a negative answer. And then 4 to the 3rd power, 4 times 4 is 16, times another 4 will give us 64. And then the last one we're going to do from this part is part L. Part L, we have negative 4 to the minus 3. Okay, that negative 3 means we're going to flip this over, and we will have 1 over negative 4 to the 3rd. And we already know what negative 4 to the 3rd is. That's negative 64. So we have 1 over negative 64, and then we just put the negative in the front. So it's negative 1/64. Now, number 4 is just like number 9. that I assigned for homework. So if you're having any problems with number 9, look back at number 4. Okay, now we're going to look at number 5. Number 5 is just like number 10 that I assigned for homework. It says use the table of powers of 5 at the right to find each of the following. For part A, we have 5 squared times 5 to the negative 3. We just need to add our exponents. So 5 to the 2 minus 3, because we have a positive 2 and a negative 3, which is 5 to the negative 1. And when we look that up in the table, we get 0.2. For part B, we have 5 squared to the negative 3. We are raising a power to a power. That means we multiply our exponents. So this is going to be 5 to the negative 6, because 2 times negative 3 is negative 6. And 5 to the negative 6 is 0.00032, which is what we would write down as our final answer. Part C, we have 5 squared over 5 to the negative 3. Okay, we are dividing numbers with exponents. That means we subtract. So we take our 5 and we write down our 2 minus a negative 3. Minus a negative means it's positive. 5 to the 2 plus 3 is 5 to the 5th power, which is 3,125, and that would be our final answer for this, 3125. Okay, part D, we have 5 to the negative 3 divided by 5 squared. Again, we're dividing, so we're going to subtract our exponents. So this time we have 5 to the negative 3 minus 2. Negative 3 minus 2 is negative 5, so it's 5 to the negative 5, which is 0.00032. Okay, so again, this was number 5, which is just like number 10 in your homework. So now we're going to look at number 6. Number 6 is just like number 11. It says copy and complete the following table for the function y equals 2 to the x by replacing each blank with either an integer or a decimal fraction. So we have our x values and we have our y values. Y equals 2 to the x. And I'm going to do this as a vertical chart, even though the book shows it as a horizontal. So if x is 4, then y is 2 to the 4th, which is 16. If x is 3, then y is 2 to the 3rd, which is 8. If x is 2, y is 2 squared, which is 4. X is 1, y is 2 to the 1st power, which is 2. When x is 0, y is 2 to the 0th power, which is 1. When x is negative 1, we have 2 to the negative 1, which means we flip this over and it's 1/2. When x is negative 2, our y is 2 to the negative 2. That means 1 over 2 squared, which is 1/4. And for negative 3, our y is 2 to the negative 3, which is 1 over 2 to the 3rd, and that is 1/8. Again, this is number 6, which is just like number 11. You don't have to graph it, you just have to complete the table. Okay, next one, number 7. Number 7 is just like number 12. So I'm going to do a sampling of the parts. Which of these symbols should replace? Okay, so we need to fill in the blanks with greater than, equals, or less than. So we have 3 to the 1 and 4 to the 1. This is part A. Well, 3 to the 1 is just 3, and 4 to the 1 is just 4. And 3 is less than 4, so less than is what goes into the blank. Part B, we have 3 to the 0 and 4 to the 0. Well, 3 to the 0 is 1, 4 to the 0 is 1. Those are equal. So we just fill in the blank with an equals. Part C, we have 3 to the negative 1 and 4 to the negative 1. Well, 3 to the negative 1 is 1 over 3. 4 to the negative 1 is 1 over 4. 1/3 is bigger than 1/4 because when you cut your pizza into 3 pieces, each piece is bigger than when you cut your pizza into 4 pieces. Okay, so now we're going to jump to part E. For part E, we have 6 to the negative 2 and 6 to the negative 3. Well, 6 to the negative 2 is 1 over 6 squared, and 6 to the negative 3 is 1 over 6 cubed. And then 1 over 6 squared means 1 over 36. 1 over 6 cubed means 1 over 216. Well, 136 is a lot bigger than 1 over 216. If you cut something into 36 pieces, those pieces are going to be a lot bigger than if you cut it into 216 pieces. So greater than is what we need. Okay, so then we have part, whoops, we want to do, for number 7, we're going to do part G, sorry. Part G is -1 to the 7th and 7 to the -1. Well, -1 to the 7th, it's inside of, the negative is inside of the parentheses, so this is going to keep its negative and be -1. 7 to the -1 is 1/7. Well, any positive number is going to be bigger than any negative number, so -1 is less than 1/7. Okay, then we will do part H, which is -10 to the -1, and then we have -10 to the -2. Okay, -10 to the -1 means 1 over -10. -10 to the -2 means 1 over -10 squared. Well, 1 over -10 is -1/10. 1 over -10 squared is 1/100th. It's positive because when you square a negative, it becomes a positive, and then when you square the 10, you get 100. Well, any positive number is bigger than any negative number. Sorry, that's a 1 there. So -1/10 is smaller than 1/100th, so that is a less than. So that's how you can approach these. And again, this was number 7, which is like number 12. So the last example I'm going to do is from number 8. Number 8 says, write each of the following expressions as a single power of x. And I'm going to skip around some here also. Part B, we have x to the -3, and it's raised to the 5th power. We are raising a power to a power. That means we multiply our exponents. So this is going to be x to the -3 times 5. That is x to the -15. Okay, part C, we have x to the 0 times x to the 10. This time we are multiplying numbers with exponents. When we multiply a number with exponents, we add the exponents. So this is x to the 0 plus 10, and that is x to the 10. Okay, part D, we have x to the 0 raised to the 10th power. We are raising a power to a power. That means that we multiply our exponents. So this is x to the 0 times 10. Well, 0 times 10 is 0, so this is x to the 0. And that's where we would stop here because that is a single power of x. You could simplify this and say that it's actually just 1, but then it's not written as a single power of x. I would accept either way. Okay, part E, we have x to the 4 times x to the -4. Multiplying two numbers with exponents, that means we add our exponents. We have x to the 4 plus a -4. Well, 4 plus -4 is 0. So we have x to the 0 again. And you can leave that as x to the 0, or you can simplify it to 1. Normally, you would always simplify this to 1, but it does ask that you write it as a single power of x. Okay, we're going to jump down to part H. We have x to the -6 raised to the -1 power. We are raising a power to a power. That means we multiply our exponents. So we have x to the -6 times -1. Sorry, that doesn't look much like a -1. -6 times -1 is a +6, so our answer is x to the +6. Now we're going to jump down to part J. Part J is 1 over x. Well, we write that down as x to the -1 because when you flip something from the denominator to the numerator or the numerator to the denominator, you just change the exponent from a positive to a negative or a negative to a positive. This is understood to be x to the 1. Okay, part K is x to the 4th divided by x to the 9th. We are dividing, so that means we subtract our exponents. X to the 4 minus 9, so that is x to the -5. And then I'm going to get a new page. 8p. Oh, and that is